This is part 2 of section 2.1. We want to find the standard form of the quadratic function represented by this graph. Okay, now you can make this problem as hard as you want to, but it's just a graph version of the ones we've just done. The vertex is where you change direction, so the vertex is the point 3, 0, and we know it passes through the point 0, 2. So we just had to use the graph to pull off the information we were given in the previous problems. So I have f of x is equal to a times x minus h, which is 3, squared plus k, which is 0. And of course, we don't need the plus 0. Plug in this information. 2 is equal to a times 0 minus 3 squared. Negative 3 squared is 9, so 2 is equal to 9a. So 2/9 is equal to a. The function we're looking for is f of x is equal to 2/9 times x minus 3 squared. Okay, so let's graph the given function by writing it in standard form, y equals a times x minus h squared plus k, and then using the transformations on y equals x squared. Find the vertex, axis of symmetry, and the x and y intercepts. Okay, we actually did a problem something like this in the last chapter, and it was at the end of a section, and I called it looking ahead. We need to complete the square on this. So what I'm going to do is first thing we have to do is we have to make sure that the number in front of our square term is 1, which we already have. So I'm going to move the 2 over to the left so that I have y minus 2. I'm leaving myself a little space here so that I don't have to recopy in a second. I have that. Now to complete the square on this, we take the number in front of our x, which is 2, divide it by 2 to get 1, and then you take that 1 and you square it to get 1. So I'm going to add 1 to both sides. So I have y minus 1 is equal to, this is a perfect square trinomial, and it factors as x minus 1 squared. Now I'll move the 1 over. I have y equals x minus 1 squared plus 1. So right here, I have it in this form. Exactly, my a value is the number in front of my square, which is 1. My h is also 1, and my k is also 1. So the vertex is hk, so 1, 1, which is there. Okay. The axis of symmetry is always the vertical line that goes through the vertex, and we generally draw it in with the dotted line. It's not technically part of the graph, but it is extremely useful when it comes to creating the graph. And it's always x equal to whatever your x value is equal to. So x equal to 1. Can't leave off the x equal to, or it's going to be wrong. Okay. My a value is positive, so it's going to be opening upward. I know that much. Okay. So if it's opening up, I should not have any x-intercepts. I'll touch on that again in a second. Let's find the y-intercept because we always have one. To find the y-intercept, you plug in x equal to 0. So if x equals 0, I have y equal to 0 minus 0 plus 2, which is 2. So my y-intercept is 2, which is right there. Okay. Now we have 2 points and we can get a third. To graph a parabola, you need the vertex, and you need at least 1 point on each side of the vertex. So right now I have the vertex and I have 1 point. I can use symmetry to get another. If I'm 1 unit away from the axis here, I'm 1 unit away on this side as well. You can plug in more points. You can just do your graph here. It's a sketch, so that's going to be good. I know there are no x-intercepts because of the shape of my graph and its location. However, if I didn't know that much immediately, what I would have done was I would have taken x squared minus 2x plus 2, set that equal to 0. To solve that, I would have gone to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. And I end up right here with 4 minus 8, so I get a negative 4 on the inside, which means there are no real solutions here, which means there's no x-intercepts.